Imagine you were deep in the dusty, ancient plains of the late Cretaceous about 70 million years ago. The heat is oppressive, the air thick with the smell of cycads and damp earth. You hear a sound, not the heavy footfalls of a giant sauropod, but a slow, deliberate rustle through the dense, swampy foliage. Then, it steps out of the gloom. It looks like a science experiment gone horribly right, or perhaps horribly wrong. It has the heavy, muscular legs and short tail of a tyrannosaur, the long, graceful neck of a giraffe, and a potbelly that suggests it just finished off an entire buffet. And then you notice the hands. Oh, the hands. Instead of 5-fingered paws or 3-fingered claws designed for gripping prey, this thing has 3 digits ending in curved, tapered keratin spikes. These aren't claws, they are scythes. They are nightmare fuel.
They are the longest claws ever documented on any known animal in the history of the planet, reaching lengths exceeding 3 feet, a full meter, from base to tip. They look like they were designed by an overly dramatic cinematic villain intent on maximum carnage. Every fiber of your being screams predator. This is clearly an apex killer, the undisputed heavyweight champion of terror. A dino normie seeing this would immediately assume it hunts Tarbosaurus for sport. But here is the twist. Here is the expectation breaker. Here is why the Therizinosaurus is perhaps the most bizarre creature that evolution ever cooked up. This absolute unit, this living Swiss Army knife of death and destruction, was an herbivore. It ate salad. Its preferred diet was foliage, leaves, twigs, and maybe the occasional ancient berry. It was essentially a gigantic, terrifying, scythe-handed goat. And that, friends, is the topic of today's deep dive on the Lost World. We are peeling back the scaly, potentially fluffy exterior of Therizinosaurus caleniformis, a name that ironically means scythe lizard turtle form, a tribute to the initial confusion surrounding its identity. We're going to figure out how something so aggressively terrifying ended up becoming the ultimate Cretaceous vegetarian. Our story begins not with a full skeleton, but with pure mystery. In 1948, a joint Soviet-Mongolian expedition was scouring the rich fossil beds of the Nemegt Formation in Mongolia. This area, often referred to as the Valley of the Dinosaurs, is a geological treasure trove, preserving a snapshot of the late Cretaceous, Maastrichtian stage, ecosystem. During this dig, led by the Russian paleontologist Yevgeny Malayev, who also named Tarbosaurus, they unearthed several fragmented remains. Specifically, they found some massive forearm bones and those 3 absolutely enormous claws. Now, remember the context of the 1940s. Dinosaur knowledge was still heavily focused on the classics, Apatosaurus, Stegosaurus, and T-Rex. Anything radically different caused mass confusion. And these claws? They didn't resemble anything known from dinosaurs. They were flattened on one side, heavily curved, and disproportionately huge compared to the associated arm bones. The initial conclusion, due to their size and somewhat strange shape, was that they belonged to a gigantic, specialized marine turtle, perhaps one that used these long structures to rake food from the seafloor, hence the specific epithet Caleniformis, turtle form. This theory, frankly, is hilarious in retrospect, but it made sense at the time, given the fragmentary nature of the finds. RIP to that initial identification, paleontologists quickly realized they were looking at something far stranger and terrestrial. For decades, the Therizinosaurus remained a ghost. Only the arms and claws were known. It wasn't until the 1970s that further findings, including pieces of its feet and hind limbs, confirmed it was a theropod, part of the lineage that gave rise to Tyrannosaurus and modern birds. This was mind-blowing. Theropods were defined by meat-eating adaptations. This creature had somehow taken the basic predatory blueprint and twisted it into an entirely new, bizarre shape. The true picture didn't solidify until the 1990s and early 2000s, with discoveries of related but smaller animals, like Alxarosaurus and Nothronicus. These relatives provided the context needed to reconstruct the full Therizinosaurus. And the reconstruction, let me tell you, is peak absurdity. When we finally put the pieces together, what emerged was an animal approximately 30 to 33 feet long, about the length of a typical school bus, and standing perhaps 16 feet tall at the hip when standing upright. It weighed in the range of 5 to 7 tons. That is the weight of a fully grown male African elephant. This was a true, absolute unit. Its body plan defied expectation. Instead of the athletic, balanced build of typical large theropods, Therizinosaurus was robust, almost dumpy. It had a massive, barrel-shaped torso that suggests an immense digestive tract, a requirement for breaking down tough, fibrous plant matter through fermentation, much like modern cattle or large megafauna. It walked on 4 toes, unlike the 3 main load-bearing toes of most theropods, a convergence with earlier, more basal dinosaurs. This gave it greater stability for carrying its heavy gut. Its legs were shorter relative to its body mass than, say, a T-Rex, suggesting it wasn't built for speed. If this thing tried to sprint, it would probably trip and become instant roadkill. Now, let's talk head. In stark contrast to the massive, bone-crushing skulls of its theropod relatives, Therizinosaurus had a remarkably small, elongated skull perched atop a long, flexible neck. This small head held a beak, rhomphotheca, covered in keratin, perfect for snipping vegetation, and tiny, weak teeth. Utterly useless for tearing flesh, but fine for stripping leaves. The brain case suggests relatively good vision and a specialized sensory system, useful for selective browsing. But the real showstopper, the reason this thing is ingrained in the collective imagination as pure nightmare fuel, remains the forelimbs. The arms were lengthy, reaching out over 7 feet, ending in those infamous claws. A 2014 biomechanical study from the University of London measured the sheer scaling of these claws. The bone core alone was massive, suggesting the entire structure, covered in a keratin sheath, making them even longer and sharper, could withstand immense lateral stress. They were curved like gigantic meat hooks, but the musculature suggested dexterity and precision, not just brute ripping force. To understand why this animal existed, we have to look at its neighborhood, the Namegged ecosystem during the Maastrichtian stage, roughly 70 million years ago. This wasn't the dry, dusty Gobi Desert we know today. This was a massive, lush river system characterized by slow-moving water, large floodplains, and dense riparian forests. Imagine a giant, slightly warmer version of the Louisiana Bayou meeting the tempered forests of modern Asia. Life here was tough, varied, and competitive. Therizinosaurus had to coexist with the largest predator in Asia, Tarbosaurus bitar, a cousin of T-Rex, slightly leaner but just as deadly. It also shared territory with the bizarre, duck-billed Saurolophus, a huge hadrosaur, the long-necked sauropod Nameggtosaurus, and, perhaps most notably, its contemporary in sheer strangeness, Deinocheirus mirificus, another absolute unit known for its immense paddle-like forearms and hump. In an environment so rich in giant herbivores, resource partitioning is key. You can't all eat the same shrubs at the same height or you starve. Sauropods like Nameggtosaurus were high-level browsers, reaching up 30 feet or more. Hadrosaurs like Saurolophus were mid to low browsers, using their specialized dental batteries to grind down tougher ferns and low-hanging branches. Therizinosaurus carved out its own niche. Based on the height of its body and the length of its neck, researchers, including those at the American Museum of Natural History, estimate it specialized in feeding on vegetation roughly 6 to 12 feet off the ground, perfectly placing it in the mid-canopy level. But how do you efficiently gather tough, woody branches from that height with a relatively small, weak beak? This is where the claws come in, solving the problem of high-volume consumption. The best current hypothesis views the claws not as weapons for killing, but as massive biological grappling hooks. Imagine standing next to a fully grown Therizinosaurus as it decides it's time for lunch. It extends those incredibly long arms, hooks 1 or 2 of those meter-long scythes around a thick branch, maybe 15 centimeters in diameter,
and uses its powerful shoulder and forearm muscles to pull the entire limb, vegetation, leaves, and all, down toward its small, snipping mouth. This technique is highly specialized. It allows the animal to access nutrient-rich foliage that might be too tough or too high for smaller browsers. The curvature and length provide maximum leverage, enabling it to bend and break even relatively large branches, acting like giant pruning shears or a leaf rake. It was efficient, it was brutal, and it was all in service of maximizing caloric intake from the Cretaceous salad bar.
This dedicated high-leverage browsing strategy explains why the claws evolved to be so ridiculously long. They needed maximum reach and maximum leverage to secure and maintain grip on heavy, resistant branches. If they were shorter, the animal would have to exert much more effort or be restricted to lower-quality food. Evolution decided, if you need a big tool, make it the biggest tool. We must pause here for a quick hydration break. While Therizinosaurus was pulling down its leafy lunch, sometimes you need something quicker and easier. You know what's nearly as painful as waiting 50 years for paleontologists to correctly identify a fragmented theropod? Trying to set up a complicated Wi-Fi mesh network in a remote excavation site. That's why we are sponsored today by PaleoPads. PaleoPads are not just insoles, they are the ultimate comfort system for the paleontologist on the go. Designed with 3 layers of proprietary memory foam that adapts perfectly to the uneven terrain of the Nemiget Formation, or even just your local natural history museum, PaleoPads guarantee maximum comfort whether you're dodging nope ropes in the desert or hauling a femur the size of a Honda Civic. They reduce the shock of unexpected fossil finds and ensure that even if your research budget gets slashed, your feet won't feel it. Head over to paleopads.com, use code LOSTWORLD15, and stop walking around like you've been stepping on broken gastroliths all day. Your feet deserve better. So, the claws were primarily designed for foraging, but to think that a weapon this terrifying would only be used for pulling down twigs is naive. In the cutthroat world of the late Cretaceous, being an absolute unit that looked like nightmare fuel was a critical survival strategy. Imagine you are Tarbosaurus. You are a massive, 2-legged tank, the undisputed apex predator. You see this bulky, slow-moving vegetarian wandering through the woods. It looks like an easy meal. A huge, slow-moving target packed with several tons of nutritious meat. Then, the Therizinosaurus stands up. This is the viral scene, the comparison that brings home the pure, terrifying utility of those scythe hands. Think of a modern grizzly bear. A grizzly on 4 legs is imposing. A grizzly that stands up on its hind legs to assert dominance, reaching 10 feet into the air, is a terrifying declaration of intent. Therizinosaurus was built to replicate and escalate that threat. Standing tall, perhaps 15 to 18 feet high when fully extended, its long arms swing into position. Now, instead of 2 paws, this thing presents a wall of 3-foot-long, razor-sharp scythes. If Tarbosaurus tries to rush the Therizinosaurus, it is met with a defense mechanism built on reach and sheer damage potential. A modern Rex had famously tiny arms. Tarbosaurus's arms were equally pathetic short king limbs. They couldn't reach the Therizinosaurus effectively. The Therizinosaurus, however, could keep the predator at bay using its incredible reach. It didn't need to pierce deep. A simple, powerful swipe across the flank or face of the Tarbosaurus would inflict massive, traumatic lacerations. These claws would act like 4 powerful, continuous whips of bone and keratin. Even a non-fatal injury, like opening up the predator's belly or blinding it, is enough to teach the Tarbosaurus a very painful lesson. Lunch is canceled. This dual-purpose function, feeding and defense, is a hallmark of successful megafauna evolution. The rhinoceros uses its horn for defense and pushing obstacles. The elephant uses its tusks for digging, stripping bark, and fighting. Therizinosaurus used the largest claws in history for harvesting its food, and incidentally, for ensuring that no one else tried to harvest it. For many dino normies, the idea that the T-Rex lineage produced a gentle giant with knitting needles for hands is baffling. But Therizinosaurus belongs firmly within the Maniraptoran group of theropods, which includes Velociraptor, Oviraptor, and ultimately, birds. Its bizarre features are extreme examples of evolutionary specialization, but they trace back to key Maniroraptoran traits: large hands, a backward-pointing pubis bone, which accommodates a large gut, common in herbivores, and feather evidence. Yes, this nightmare-clawed absolute unit was almost certainly covered in some form of feathering. We don't have direct fossilized feathers for T. chilenormithus itself, but we do for its close relatives. Bapiosaurus, an earlier, smaller therizinosaur, shows clear evidence of filamentous feathers, simple hair-like structures. It is highly probable, based on phylogenetic bracketing, that the massive Therizinosaurus was covered in dense, insulating plumage.
Imagine that scene again, the giant, scary monster stepping out of the shadows. It's not a scaled brute, it's a huge, angry-looking feathered animal, perhaps with iridescent plumage, wielding twin scythes. It's a giant, fluffy, murderous-looking turkey that just wants to eat its leaves in peace. The absurdity is peak Mesozoic design. Paleontologists studying its feet also noted the unique arrangement: 4 functional, weight-bearing toes. This feature, unusual for a Coelurosaurian theropod, further reinforces the idea that it was adapting heavily for a terrestrial, high-mass herbivorous life. A 2023 study by researchers at the University of Alberta suggested that this foot structure helped distribute the immense pressure created by its gut, allowing it to navigate soft, swampy terrain without sinking too deeply, a crucial adaptation in the Nemegt floodplains. We often talk about the great evolutionary transitions: fish to amphibian, reptile to bird. But the shift from a swift, small-toothed predator, the ancestral Maniraptoran plan, to a slow-moving 7-ton specialized herbivore is one of the most drastic and successful dietary shifts in dinosaur history. It's a beautiful illustration of how niche availability drives extreme morphology. When there's a gap in the ecosystem, the mid-level canopy browser, evolution will fill it, no matter how bizarre the resulting creature looks. The legacy of Therizinosaurus is not one of terrifying carnage, but of successful adaptation. It proves that the most visually aggressive features don't always denote aggression in lifestyle. The lion's mane is mostly for display. The moose's antlers are for sparring with rivals, not necessarily killing prey. For the Therizinosaurus, those record-breaking claws were fundamentally optimized for gathering the tough, woody resources that fueled its colossal digestive engine.
They allowed the animal to become one of the most dominant and successful herbivores in its environment, minimizing competition and maximizing caloric intake. If it was also an intimidating, fluffy defender that caused a predator like Tarbosaurus to immediately file a restraining order, that was just a very happy accident of evolution. The Therizinosaurus is a powerful lesson for every dino normie out there. Never judge a dinosaur by its claws. Its very existence challenges our simplistic understanding of the theropod family. It's a testament to the fact that evolution doesn't have rules. It just has problems to solve. And sometimes, solving the problem of how to reach high leaves results in a creature that looks like the protagonist of a slasher film. We will never stop being fascinated by this gentle giant that looked like pure nightmare fuel. It's one of the greatest paradoxes of the Lost World. Thanks for watching, and until next time on The Lost World.